Welcome to this video on denoising your renders in Arnold for Maya. It's probably going to be the most exciting tutorial you've ever watched. I'm going to talk about a couple different methods, including the Noice denoiser, not to be confused with Nice, although your renders will look a lot nicer once they're denoised. I'll also talk about the OIDN method, which is the Open Image Denoiser. In addition to that, I'll talk about when either of those methods will be most beneficial for you, depending on if you're rendering a full frame animation or just a single frame render. Now, of course, the biggest upside to denoising in general would be that we can achieve a clean, high quality final result and not have to skyrocket those samples, resulting in longer render times. Now, there is a third option, which is optics. It's available for you fortunate Windows users out there. Unfortunately, not for us lowly Mac users, as it relies on NVIDIA's CUDA, which is not supported by Apple. But that said, I will provide a link in the description below to a video that goes over how to use the optics method for you Windows folks. But enough of that, let's jump on in and get our denoising game on. So first of all, the scene that I'm working in here, I downloaded from Autodesk's website within the resource section. I'll provide a link to that within the description so you can download it if you'd like. I have modified it a bit from its default state. I've added an HDRI, and then I also rotated the sun a little bit and adjusted its color. I've moved the camera back. First of all, I just kind of selected its transforms, right-clicked, unlocked the selected, and then moved it, rotated it slightly, then relocked them so I didn't accidentally move it. But anyways, working with this as a starting point, let's jump into the Noice denoise option. So first of all, this is Arnold's high quality AI driven denoiser that runs after rendering. It's great for animation, primarily because it maintains temporal stability, meaning that your frames won't flicker. Since it's a post-processing tool, you also won't see its effects in real time while rendering. It is good still for single frames to kind of apply as a post-processing effect. So first of all, to show you that, I'm just going to bring up the Arnold Render window. So if we bring that up, you can do that by going to the Arnold tab within your shelf. You'll see this button. You can click that arrow button, or you can go up to Arnold in the top of the Maya UI and then click on Open Arnold Render View. All right, so with the Arnold Render View open here, you can see I've done a render of the modified scene here. And as you can see, it's pretty noisy. So I would want to start kind of applying some denoising to it at this point. You would end up ultimately refining it a bit once you start adding your final materials and textures to the scene. But in any case, this will work for demonstration purposes. So to add a Noice denoising to it, what we can do is go over to the display settings cog in the top right of the Arnold Render View here. It'll pop out these tabs here with the post tab defaulted as being visible. And so what we're going to want to do in order to apply some Noice denoising to this image is go to the Add Imager dropdown, and then you can click on the Imager Denoiser Noice 1. There's a few here with different presets. But let's just start out with that one. Let's use that one here. So once we apply that, you'll see it starts to kind of go over the render again and apply that imager to it. So I'm just going to hit the pause button and we'll jump back with these settings applied to it. All right, so this is what it looks like with the Noice imager applied to it, doing its thing, nice and cleaned up, looking great. You might have noticed before too, I did have some extra AOVs specified within this layer selection input box here. That I think was just settings it had retained or held on to, maybe through some sort of cache when I had the file open previously that was connected to this Noice 1 imager. So I've just deleted those, and I just have the RGBA specified in there now. That's kind of more in line with what I believe the default settings might be. But in any case, when I did that, it just applied it right to the beauty pass and just kind of baked it in there after the fact. But that's how it looks. Looks great. It looks cleaned up. Looks good to go. Now I do have those two light group AOVs active within the scene. And so to create those, I just clicked on my two primary light sources. So my directional being the sunlight, which I have adjusted the color on and rotated, as I stated earlier. And then you go down to the Arnold dropdown, go to the light group, AOV light group input box, and then I just specified it as sun. since it is my sunlight. And then I went to the sky dome and then made that one the sky light group. So after doing that, I went to the render settings, made sure Arnold Renderer was specified, it should be already. And then I went to the AOVs tab and then created 2 custom AOVs and then made sure I had the prefix RGBA underscore for it in order to get those light groups working. You do need that added within the name. And then you should get them working for you. When you do a render, you should see that result. So now, of course, we would want to also denoise those if we do intend on using those after the fact, maybe in some sort of compositing program. And so to do that, we would want to add those to the layer selection here. So it's pretty simple. You just click on the Select AOVs button here, Shift select all of them, click OK. It'll add them in here, separating each one with OR. And then when we do that, you'll see it start to kind of go over the render again. And now I'm just going to pause the video, and when I come back, we'll see that applied to those light group AOVs. All right, so now that render is finished with the light group AOVs added within the layer selection. So now if we look at the light group or AOV drop down here, we'll see that the light group AOVs are now denoised. They look cleaned up and ready to go, ready to be composited. So I'm just going to go back to the beauty here. You'll see I've also saved out a snapshot of it as well, just to kind of be able to compare back to as we continue to move along here. With that said, now we can just go File, Save Image, or go File, Save Multi-Layer EXR. I'll typically save a multi-layer EXR for compositing purposes. But let's just jump over to Nuke now. I'm just going to show you how we can kind of practically use this within Nuke. All right, so here we are in Nuke. You'll see I've saved out the image as that multi-layer EXR. Here it is here. If we just view it there, that's that result. And then I've also created 2 shuffle nodes. So to create a shuffle node, you can just go Tab, type in shuffle, arrow down, hit enter, and there you go. There's that shuffle node. And if you don't have Nuke, by the way, you can get the non-commercial version for free from the Foundry's website. I will post a link to that in the description if you don't have it. Just moving forward with these shuffle nodes, if we double click on that and we go to the properties panel, I'm just going to limit these to 2 here so we have less clutter. But if we double click on the shuffle node, and you'll see that I've set the input layer to RGBA sun, and then the output is set to RGBA, and then I've just connected all of these here as well, the red, green, and blue, so that the light group information is just piping right into the RGBA output of this shuffle, so that when we view it, we get that sun light group as being the final result coming out of that. And then I did the same thing here with the light group sky here, so the sky light group. And then I created a merge here, just kept it as over for the operation. And now we're getting the exact same result as the original render, which is exactly what we want. Because now we can just say create a grade if we want to, plop it in there, and then we can reduce the intensity of that sunlight. And we have complete independent control over that light group. We can change the color of it if we wanted to, maybe warm it up a bit. And then we could also, make a grade, put it on the skylight group. We could maybe darken that down a little bit, and maybe we want to brighten that up again to compensate slightly. There we go. And then maybe we want to cool it off as well. But that's that kind of independent control and advantage that rendering out light groups gives you. So there's just a little mini light group tutorial as well. But that just kind of shows us the advantage, right? So if we didn't denoise those light group AOVs, we wouldn't be able to do this, right? Because we would have a noisy, low quality final result that we would be working with, because we would just be working off of those noisy AOVs. But now let's jump back into Maya. All right, before we get into adjusting the variance, where I'm just going to show you quickly what adjusting that value specifically does for us in terms of the final denoised result. If you add an output suffix here, say underscore denoise, what it will do is it'll create a secondary AOV output for each of the AOVs that we've created, whether that's the RGBA or any light groups or anything else, any other AOVs that we might have active within our scene. here. And so what that would do is it just kind of preserves the original beauty render and any AOVs that you might have active, so that you can compare those in terms of the before and after. It also gives you more compositing flexibility, letting you potentially blend between the denoised and original version in post. And the Noice denoiser might also introduce some artifacts. And so you can also apply that selectively in compositing rather than committing to it in the render itself. So it just gives you a little bit more flexibility. That said, it does increase your file size, adds another layer of complexity to the final output. And it might not always necessarily be necessary. So, but it is an option for you if you do want to do it that way. But with that applied here, I'm just going to refresh my render and show you what that would look like. All right, now that render is finished, I've gone ahead and saved a snapshot of it as well. And if we go over to the AOVs dropdown, you'll see that we have those kind of secondary denoise AOVs listed here. And so if we click on those, you'll see we get that result with them cleaned up and denoised right there. And so they're ready to be composited and used in any way that you might want to use them. Now, typically, again, I would probably just not have the suffix appended to the final result, and then just have the denoise baked right into my active AOVs, whatever those may be in any given project that I'm working on. However, that is an option available to you, and so that's how you would separate out your denoise AOVs. In that way. All right, next, I'm just going to go over these values here just briefly. I'll also provide a link in the description to some documentation on Autodesk's website, where they also have some resources talking about denoising. I'm not sure if they have a section specifically that goes over these, but I'll just touch on these briefly in any case. So first of all, the patch radius here. That will kind of define the size of the area around each pixel that's used to analyze the noise patterns within your render. A higher value can smooth out the noise, but will also increase your render times. And then the search radius, that one will determine how far Noice looks for similar noise patterns within your render. So a higher value of this will also smooth out your noise more effectively. However, it will result in increased processing time and most likely render times overall. And then your variance value here, that will control how aggressively Noice removes noise. And so a lower value will preserve more detail within your image. However, you might see more visible noise, whereas a higher value will remove more noise from your image, but will also risk softening the textures, the details, and just kind of smudging things out a little bit too much in some cases. So as you can see here, I've used 0.5 as my working value here that I've tested. I do think that that is a sufficient value to use as a working value in the current scene here. You will often, again, just end up refining that once you start adding textures and materials to it, but I think 0.5 works quite well here. So I'm just going to do a render or a separate pass with it at 0.25 and then at 1. And then just show you what that looks like in action. All right, so I've gone ahead and done a couple more renders with the variance value at 0.25 and 1 here. And so that's just to illustrate the difference between them again. So with it at 0.25, we can see, as described earlier, that we get more detail visible within the frame, within the render overall. However, we have now introduced a little bit more noise. And now in various cases, it might not be as noticeable again once you start adding textures to the scene, but I do think that this would be more than I would probably want once the render is getting closer to final. Here it is at 1. So this looks very cleaned up. There's effectively no noise visible really. However, we are starting to see some detail getting blurred out, geometry detail, and if we had textures in here, I'm sure that would start to get blurred out as well here. We're also starting to see some of the shadow information getting smudged out, like under this cable or piece of geometry here, whereas 0.25, it's clearly visible. The highlight on that floorboard is clearly visible, whereas here it's just starting to get smudged out almost completely in some areas. So I'd probably avoid a value of 1, at least in this project here. But again, 0.5 seems like that safe middle ground where we still retain enough detail, but we also still have a very clean denoised image here that we're working with. Okay, so that's a quick go over of how we can use the Noice denoiser within the Arnold Render View here. Next, I'm going to show you how we can use it through the terminal to apply denoising to multiple frame animations where we might have moving cameras or just where we're rendering multiple frames. But anyways, I'm just going to pause the video and we'll jump back in. All right, so before we jump into terminal itself, I just want to touch on when you would use this method. So typically you would use the terminal approach to denoise your images if you're rendering multiple frames, an image sequence, as it were, some sort of animation. Whereas the previous method, when you're just saving right out of the Arnold Render View, would of course just commonly be used if you're looking to denoise a single frame render. So first of all, when you're using this method of using the terminal or the command line if you're on Windows, you're going to want to make sure that your project is set so that your renders go to the proper directory within your project. So first of all, you're going to want to go File and then Project Window. Ensure that you've established your project name, and where it will be saved out to and the corresponding data information within that project as well. It's always good as well just to make sure that you have your project set. If you've closed Maya, reopen the scene and whatnot, just to ensure again that your images are going to render to the proper directory when you batch render them. And so as well, I just have my file name prefix just undefined there. It's just going to use the scene name, the default. I have the image format set to EXR. I'm merging my AOVs so they all render into the same single EXR file. I'm using a single frame render just for demonstration purposes. You could of course change this to name, number, extension, or what have you if you're doing a multiple frame animated image sequence. You can establish your frame range here, set your render camera resolution, all of that. And then my render settings are just defaulted to what they were when I downloaded the file here. You're also going to want to make sure output denoising AOVs is ticked off in your AOVs tab of your render settings. That is essential to make sure that this will work. And then I also have, again, as you can see, I still have my light group AOVs active here in this case. Now, of course, you don't need those. This could be empty. You don't need any active AOVs listed here explicitly. As long as you have this ticked off, you should be good. That said, though, I'm just going to jump into Blender since I think that'll be the easiest just to kind of show you what a batch rendered image will look like with this denoising AOV information included within it. And that'll just make sure, again, that the proper metadata AOV information is added to those renders. All right, so here we are. I've just batch rendered out a single frame and I brought it into Blender. I just dragged it in and then I'm just going to go Shift Control left click. And that's what we're viewing already right there, just that beauty render. And then it also includes the n_Noice, that is the normals pass, and then the z_Noice for the depth information. And then it also includes the color pass, so the denoise albedo noise pass as well as the variance. And so those are all essential for this to work. And just by ticking off that checkbox again, it'll make sure that all of this is included by default. And then as you'll see, it also has the light group AOVs included in this as well because I kept those active. But as you can see, they are noisy still, so we would want to clean this up. The light groups and the beauty pass are still noisy. So I'm just going to jump back into Maya real quick. All right, so in case you don't already know, to batch render your scene, again, once you've established your project, set your project, you have your images rendering out within that, to your images directory here. You can also change that by just like, I believe adding like a slash if you want, or you can just change this to scene and then slash, and then it'll name in the folder your scene name. And then you can just put your, you can maybe have your file named the scene name as well, with the extension at the end of it. You can set that up however you'd like, of course. But again, it is important just to have that set. Once you have that set up, you can go to Render, Batch Render, And then it'll render out your frame, whether you have that set to single frame or you're doing a whole sequence, a range. They'll start to render out within your directory. You should start seeing your images render out within that specified path. And now they'll take as long as you might expect them to take based off of your images that you may have rendered within Arnold. And I'm going to stop that. Didn't want to do that, but yeah, just based off of this, right? Like they'll just take as long as they would have taken otherwise here, which I believe for me, this was like 3 minutes per frame or something like that. But you should start to see those even just pop up right away. It'll just be a smaller file size. It might say like 33 kilobytes and then it'll finish and say like 30 megs or something like that. But once they finish and you see all of your frames have rendered, that's when you can go in and start this denoising process using the terminal or again, command line in Windows. So again, you just go render, batch render, and I'm gonna go over to the Finder and Terminal window to show you the next step. Actually, sorry, there is one more thing that we have to do here, and that is just to ensure that the light group AOVs get denoised. What you're gonna wanna do is go to your AOVs tab again, and then at the bottom where we have our AOVs drop down, and you'll see those light group AOVs specified. Any active AOVs will also be located down here with this extra information. So what you're going to want to do is go to this little arrow to the right of the filter drop down, and then go to add new output driver. And then when you do that, this should pop up here for each of these as you do that for each of these. And then you're going to want to specify that second output driver to be set to variance. And that'll ensure that these light group AOVs have their own kind of variance information, so that when we run the denoise operation, they also get denoised in addition to the beauty pass, the default RGBA that is. So once we have that set up though, then we can go over to the Finder and Terminal and I'll show you that next step. All right, so here we are. As you can see, I have my Finder up on the left, a fresh terminal on the right, and the batch rendered single frame render here within my images folder of my project directory. And that is the denoised image, as you can see, or sorry, noisy image that is. And so we're just gonna wanna denoise that, clean it right up. And so what I'm gonna do here next is I'm just gonna paste some code into the terminal. And that looks like this. And so this is just running a bit of a function here that is just defining the path to the Noice executable within the Arnold directory inside the applications folder. And so that's, I believe, established by using the cd command here. And then it's pointing again to the Noice executable, and then we're establishing the input image here and the path where that's located. And so that is just pointing to this guy right here. And then we're then defining the output path as well again, and then the name in terms of what we want that file to be named. And so I've just added on here just the suffix underscore denoised. And then over here, we also have the additional AOVs that we want to have denoised. We're just kind of specifying that here. So we're having the RGBA, sun and sky denoised. And so those will then be denoised since we have those variance outputs included within the AOV information. And so now what we can do is just hit enter and run this, and then we should see that file just pop up in that directory. And there we go. So as you can see, it's just named the exact same with denoised again, just on the end of it there, as we would expect. And so now I'm just going to bring that into Nuke and we can see what that looks like. All right, so here we are in Nuke. Again, this is the non-commercial version. You can find a link to that in the description. Now I've also brought in both the single frame batch render version prior to it being denoised, as you can see here. And then I've also brought in the denoised version after that terminal command has been run. Now it looks all nice, cleaned up and denoised. Now I'm just going to create a shuffle node by hitting tab, and then I'm going to type in shuffle arrow down, hit enter, and that will create that shuffle for us. Now if we click on that AOV dropdown, as you can see, we have all of the necessary denoising information, the n_noise, the denoise albedo noise, as well as the variance is coming from having the output denoising AOVs checkbox ticked off in our render settings in Maya. And the _1_1 for both of these corresponding light groups, that result is coming from having created a secondary output for both of the light group AOVs, and then we set that filter to variance, and so that's what we're seeing here. Now again, if we look at the final result of the light groups, they currently look noisy. If we look at the sun as well as the sky and going back to the RGBA, they are still noisy. However, that necessary denoising information still exists, and so once we have run that command to denoise it, it's consolidating that information. If we just plug that B input into that result, that denoised result, and now make sure we're viewing that shuffle, you'll see now we have that final cleaned up render. It's kind of consolidated that information to make sure that it is working for us. And then now if we view our light groups as well, those are cleaned up, denoised, and ready to go. And so now this final image is ready to be composited as needed within our compositing application of choice, whether that's Nuke or Blender or what have you. We can push and pull those values of those light groups if we decide to use those, and we are good to go. All right, so I'm just back here with the Finder and terminal up. Just opened up a new one, pasted that code back in. I just wanted to show you, if you are using a more of a simplified setup and you don't have any of those extra light group AOVs and just the RGBA or beauty pass that you want to have denoised, what you would do is hopefully kind of self-evident, but everything would stay the same, right? So you would establish your path where the Noice executable is, and then your input image, output image with that suffix. This line would stay the same. You would just have this line here just be RGBA, and then you would just remove those or not include those extra AOVs, and only the one that you want denoised. In this case, if it's just the RGBA, we would just have the RGBA here. But that's it, right? So it would just be a little bit more simplified, but that's all you would need to include in that case. That being said, I'm just going to jump back into Maya and quickly go over an alternate option for denoising multiple frame renders. All right, for this method, you would go up to Arnold at the top of the Maya UI, and then you would go down to Utilities, Arnold Denoiser, brackets, it says Noice, as that is the only option for this method. And then you'll see a window pop up, and you'll see an input box as well as an output box. Input box, that's where you go to specify your renders, your images that you want to have denoised that are yet to be denoised. So that would be your batch rendered single frame or multiple frame animation, image sequence, or what have you, depending on where that is located. You can just click the three dots there and then navigate to that directory where you have your renders located on your hard drive. And then you can just select that image that you want denoised, hit select. I'm just going to hit cancel. I had selected this initially just as a test, and then it'll have that specified there in the input box. And then for your output, you can put that in the exact same directory if you want. It'll just place all of your denoised images, whether it's a single frame or the whole sequence, in that same directory. Or you can create a new one. So that's what I did. I created this test folder, and then as you can see here, I just made sure that it was included in the path, and then added on the suffix _denoised just to make it clear that those were the denoised images. You wouldn't necessarily need that. You could just put it in a folder maybe that says denoise, maybe it's named denoise, and then your images just go directly in there and they're named the same otherwise. That's up to you. And then for the frame range drop down, you can specify if you want just a single frame denoised, or you can select start to end, where you can specify a start and end frame that you want denoised, or you can select complete sequence. That will just render the entire sequence. So this is grayed out. And then you can specify your Noice settings. We looked at this a little bit earlier, so you can specify those here as well. And then you can also specify the light groups that you want to make sure are denoised based off of what you have active. Maybe you have some light groups or something else. Again, you can separate those with OR, copy that right out of your Arnold Render View. If you've already done a test render, that should exist there. So you can just copy that right into here, or just type it out, use OR, and that should work too. I'm going to set this back to single frame as that's what I tested with. And then you just hit denoise. Once that's run, it should just output those denoised frames into the directory that you've specified as you've specified it to be, with the file name and all of that. And so now if we navigate just to that test directory, you'll see that image is in there and it is denoised. So now if we just bounce into Nuke, you'll see what it looks like. All right, so here we are in Nuke, and this is that exact image that I've brought in here. Again, looking at it from the shuffle, if we just view the RGBA, we'll see it's denoised. We'll see it's kind of consolidated all of that denoise information so we don't have those extra AOVs. And now if we look at the light groups, it's denoised, the sky as well as the sun. And so it's good to go. So that is another method, more user-friendly than the terminal. And that works as well. So you got multiple ways to go at this, but there is also that option. Now I also have a link in the description to another video that goes over this option in case I missed something. And now there is one other option that I found just kind of through trial and error that I'm going to go over next. It's pretty user-friendly. It's just basically through a straight up batch render. Right when it comes out, it will be denoised. So it kind of eliminates an extra step, which is nice. So I'm going to go over that next. All right, so for this next method, it's just applying the imager again, right? So it's just applying the Noice denoiser imager and making sure that it's enabled, right? So if it's disabled, if we turn that off there, it'll turn it off in both places. You can click this checkbox here to do that and turn it on to enable it, or you can just click this over here, this icon, and that'll disable it and enable it. And when we do that, it'll do it in both places as you saw there. So we will, again, of course, want to make sure that it is enabled here for this approach. And now when you do that, you're also going to want to make sure your settings are set up as they were before, and make sure it's set to 0.5 there. I'm not sure if that'll actually carry over if it's set this way in the Arnold Render View. But in any case, it's better to be safe than sorry. I'll maybe post in the description later if this actually sticks or anything, but you might have to set that separately in the render settings. But in any case, you do want to make sure that that is enabled here. Once you have confirmed that, if you go over to the comment tab, you'll see that have this set to CNC, and I just removed the extension after modifying it before. So it's going to save these renders into a folder named after the scene within the images directory as specified here at the top of the comment tab. And then it's going to name the files after the scene as well with the frame number at the end. So let's jump into the Finder next, and I'm just going to show you what that looks like. All right, here we are, and as we can see within the Finder here, we have those frames rendered out. We have 3 frames. More illustrative of an image sequence or animation, of course, here. So I just have it name number extension. We have frame 1, 2, and 3, and there they are. So let's just bring one of those into Nuke, and I'll show you what that looks like. All right, here we are in Nuke. I just brought this image in here, and as we can see, it looks all denoised and cleaned up. This is just straight after batch rendering it. I didn't run any terminal commands or anything. This is just what it looks like with that imager enabled. So it looks good. And now I've also created this shuffle node, and if we look at the light groups, RGBA sky, it's denoised, as is the sun light group. There's the variance information for that. It just looks kind of weird, but hey, it works. And I believe that does work again, just because we do have that secondary output that we've created with the filter set to variance for those light groups. And so that ensures that they will be denoised after that imager is applied to it and it's batch rendered out. But in any case, as you can see, it seems to do the trick. So I haven't tested this extensively. I would recommend giving it a go though and testing it yourself. If it does work, as it seems to, it would be the simplest approach, especially compared to the terminal method when doing animations. But next we're going to jump in and look at the OIDN denoiser approach within Maya inside the Arnold Render View. That'll allow us to do some denoising interactively with our progressive renders. All right, so for the OIDN denoiser, you'll see I've removed the Noice imager. I just right-clicked on it, and then I went Remove Imager, and then I added the OIDN denoiser, the imager for that. So I just clicked on the imager menu, went down to denoiser OIDN, added that. Again, that is Open Image Denoiser, and so I've added that there. The default settings work. If you want to have it denoise your other AOVs, you can do that using the same method we went over previously, just by clicking this button here. And then it'll denoise your RGBA along with any other specified AOVs. In addition to that, you'll see I've went ahead and deleted those secondary outputs. With those in place, it was throwing me an error and it wasn't denoising it as I wanted it to. So I just deleted those for the purposes of this demonstration. Now, if I just click off of the snapshot here, you'll see it in action here. So now, of course, it looks a little bit smudged out, as you can see, but that's just because it's paused. This was just an interactive render that I had paused. So if we just hit play on it again, we'll see it denoising. And so this is something that is beneficial using this method, in that you can see your result being denoised progressively as your render starts to refine itself. Whereas with the Noice imager, you can't do this, right? So you'll just have to render your image and then it'll denoise it after the fact. And so this is just a little bit more interactive, where you see that kind of cleaned up result as you're working on your scene, which can be helpful if you want to see it more cleaned up as you're kind of just, again, progressively working on it. It's similar to checking off the denoise checkbox in Blender, if you've done that before, where it'll just interactively denoise your image as you're working, for example, within the viewport there. So this is one method that you can do to do it this way. Now, I wouldn't render animations with this. I'll post some documentation, perhaps as an overlay over the video, just showing why you wouldn't want to do that. It's not very good for frame-by-frame denoising compared to Noice. You would probably see some bouncing around artifacts, etc., as it wouldn't denoise frame-to-frame one-to-one. So this is more for single-frame denoising or just interactive denoising as you're working on a project. But anyways, that is how you use the OIDN denoiser within Maya. That's the primary method that I'm aware of anyways. But that about sums up the denoising methods within Arnold for Maya. Again, you can use the denoise optics option here as well if you're on a Windows machine, and that is also an option. Again, I'll post a link to that within the description for this video, where you can see how that's done for you fortunate Windows users out there. But aside from that, that is how you can denoise your images, again, with Arnold. Hope you enjoyed the video, got something from it, and I'll see you in the next one. Feel free as well to like and subscribe, and until next time.